Chris Hatfield.
Mm-hmm.
Joe.
The guy who never smiles. He doesn't smile, dude.
Not all the Russians are funny.
He was funny though. He said at the crew debrief, "Hey, look."
Oh.
At the crew debrief, some of them asked, you guys are going on your 6th or 7th space flights. Why do you keep going back? And he said, "I'm a cosmonaut. It's my job."
That is funny.
Oh, I know where we are. We were here last time.
I haven't been to this part.
It's cool.
Hey, another I can tell. You're all kind of drag one. Let me go back a little. Sure. Not a problem.
You can't drag a bunch of people through pictures like that. I'm Tom.
I'm Heather.
Heather, nice to meet you.
Hi.
Hi.
Hello.
Hey.
You guys having fun today?
Yeah.
Ma'am.
Blowing your mind?
Mm-hmm.
Is it this one? Yes. Good.
How you doing?
When I get done, I'll be like, what? I don't know what
I need to do something. Next time we go to a press conference, photobomb it with the Texas Tech, whatever y'all do.
Oh yeah, wreck 'em.
Because I was sitting in the back. There you go. The guy sitting next to me was taking a picture, and I'm just sitting back. Every time the camera, there you go.
You should have popped it over Joanne's shoulder. Wreck 'em. News conference.
Oh, how was that?
It was a lot of fun.
Perfect.
It was really
Sure.
cool, yeah.
I'm a little jealous.
You were sitting here waiting for us.
Yeah, that's okay.
Oh my gosh.
I was.
Hey everyone, this is Heather Paul, spacesuit engineer among many other things. She, I think, is going to tell you all about spacesuits.
Yes.
Good deal.
Well, welcome. You guys can come this way because this is still an office area. So
Very good. Sure.
I'll tell you in hushed tones. I'm just kidding. So first of all, I'd like to welcome all of you. Thanks so much for coming to JSC today. It's always a huge pleasure for us to showcase all of our engineers and our hardware and our capabilities to all of you. So thank you on behalf of me personally and my engineering division for coming to visit us. So my name is Heather Paul, and I'm one of the mechanical engineers here at the Johnson Space Center. I've worked here for 17 and a half years. Please don't start thinking about my age.
Wow. Look a day when
You don't look. That's right. Yeah. Were you 3 when you started here?
No,
Yeah.
yes, maybe 5 years.
I really like you guys. Thank you.
Don't look a day over 17.
Thank you. Really, seriously. So where are we going next, guys? No, I did start here when I was 19. So again, don't do the math. But I started as a cooperative education student, and I started in life sciences. And my second student tour here was in this very division, and this is where I really fell in love with designing hardware for humans to use in space, whether we're on the space station or some other really interesting destination. So our division does everything. We're called crew and thermal systems. So really anything crew related, whether it's where they sleep, where they eat, where they live, where they work. We do a lot of the crew quarters design and evaluation, and a lot of the testing of hardware that the crew wants to take up with them, making sure everything is going to be safe for flight and it's not going to off-gas any contaminants or anything toxic.
You couldn't have given them a little more room to live in up there?
We tried. It's pretty expensive to launch things into space, so you know. But hey, it's a 5-story house, five-bedroom house, basically. You know, really, they have like a bay window, 4 different laboratories to do
Well, I was
science
just thinking of the
in.
little quick cubicle that they sleep in.
Ah.
That one.
Well, I think that's so they don't really float around as much too, and they like to kind of close it off. But you know. So, and then crew survival equipment, everything they need to survive the launch and re-entry, especially during the Space Shuttle program, now eventually in the Orion program. And then, of course, our spacesuits, which we're going to delve into here in a moment. And then all of the thermal design and analysis associated with a lot of the materials that are on space station to make sure that what we send up there can really withstand the extreme environment. Okay. So, when we're orbiting around our planet at 17,500 miles per hour, we have a 90-minute orbit, and what that means is when you go outside, you definitely need some protection, right? Yes.
Yeah.
First of all, there is a lack of atmosphere, so you won't have any oxygen to breathe, but then there's also the extreme temperatures where materials can get up to 250 degrees Fahrenheit, and then down to minus 250. So over that hour and a half, you're seeing a 500 degree Fahrenheit delta in temperature. Now, I don't know about you guys, but I'm pretty sensitive to temperature extremes. It was 87 here yesterday, okay? And I was thinking, I'm not wearing a long sleeve shirt. Now it's dropped down into the 70s, and all of a sudden I'm wearing a scarf, you know, a longer sleeve shirt. I even have a sweater for when I get a little bit chilly. And that's only 10 degrees.
I just came from minus 32 degrees in Finland. Centigrade.
Wow.
Oh, there you go.
Okay.
All right.
So you're definitely
So I'm
wearing
just-
something much different than you were
Just
there.
trying to get acclimated back to normal here.
Well, the human body, we're so sensitive to temperature variations, not only physiologically, but just, I mean, fundamentally. So for comfort and also for survival. So when you go outside of your space vehicle, like what we did on the first Gemini spacewalk on June 3rd, 1965 with Ed White, we needed a suit that was going to protect him from the harsh environment of space. Well, before we even started with that, we had the Mercury program. So taking our first astronauts into space. It was a very interesting time for the United States. We were a little bit in competition with some of our current partners, but we wanted to prove that we could not only send people up into space, but have them live there for a period of time and eventually longer than just a few minutes. So the Mercury suit that we have here is fairly simple compared to what we designed over time. As our space missions got more complex, so did the hardware that we needed to design and build for astronauts. So the Mercury suit is really just what we would call an emergency suit or a get-me-down suit. It was something that the astronaut wore inside of the crew compartment. He stayed seated the entire time. So if you can imagine sitting down in a chair, upright, strapped in, and the only movement you need to do is with your arms at your shoulder joint because all of the controls for your space vehicle are within arm's reach. Now there was a swivel here so that our astronaut could swivel and look side to side. But really, this suit design was meant for comfort in a seated position when pressurized, when inflated with oxygen. Now in contrast, once we proved we could send humans into space, it certainly wasn't enough. Where are you guys from?
Here.
Washington, D.C.
You all look so surprised I asked you a question. Washington, Kansas, Texas.
Wimberley, Texas.
Wimberley, Texas. You just flew in from Finland. Wow. So you guys have maybe taken some time to get here, whether you've driven or whether you've flown or whatever mode of transportation that you had. So can you imagine what you would have felt like if you got all excited about the NASA social event today? You traveled that long distance to get here, and all you could do was look out the window, and then go back home.
Right.
Yes. Well, now you can imagine that when we started looking at future space missions beyond just sending people up into space and coming back down, it was very exciting when all of a sudden our President John F. Kennedy said, I don't want you to just send people into space. I want you to send them to a destination, the moon. I want to do science there. I want to do science in microgravity. So all of a sudden, NASA had a big challenge ahead because now we needed a new vehicle, one that was big enough in a Gemini mission to house 2 astronauts instead of 1. Equipment that would allow our astronaut to go outside during an extravehicular activity or a spacewalk. So Ed White in the Gemini mission went outside for only approximately 20 minutes. His spacesuit kept him alive during that time. That's about all it did. We realized we had not designed the suit for enough comfort and mobility in a microgravity environment. It's very hard to simulate microgravity here on Earth. We can do it in a swimming pool, but you've got the drag forces of water that you have to work against. We can do it on a plane, but only for about 20 to 30 seconds. So really, Ed White on that first spacewalk was our first official microgravity test subject. Lucky guy.
Poor guy.
And during his 20-minute spacewalk, he became extremely overheated and tired, to the point that it took him a long time, several hours in fact, when he came inside from being out on the spacewalk, to calm his body temperature down. So our flight doctors looked at this, our engineers looked at this, and we realized that we needed to make a lot of different modifications, not only to our Gemini spacesuit, but eventually to the Apollo spacesuit. So now the Gemini spacesuit, Mercury was designed for seated comfort, pressurized, only mobility at the shoulders and at the helmet. Gemini was now hopefully designed to be a little bit more mobile at the hips and shoulders. And we even had this device right here that was in a maneuvering unit. Well, we had so many problems maneuvering in space, we realized we needed something a little bit better. So the Gemini spacesuit worked for what it needed to do, but really what it did was exactly what we needed, in that it gave us the test capability to understand what we need to do to continue to redesign our suits for better, more successful microgravity spacewalks. So now we can head to the moon. It took 2 to 3 days to get to the moon. It only took us about 4 seconds. Right here.
Technology is amazing.
I'm here all week.
And twice on Thursday.
Yeah, exactly.
Accomplished so much in 17 years.
Thank you. Thank you. Okay, so I love this display here because it really shows you the different aspects of the Apollo spacesuit that we designed. The initial missions for Apollo, we went out for about 3 to 4 hours on a spacewalk. Apollos 15, 16, and 17, we upped that duration to 6 to 8 hours, and we included a rover. So now, let's go back in time. Mercury was designed for seated comfort, well, relative comfort. Gemini, extravehicular activity capability, so now seated and floating. The Apollo suit had to be designed for comfort, flexibility, and work efficiency when you were seated, launching and re-entering from the Earth, when you were floating, if you were on a microgravity spacewalk, when you landed on the moon, when you walked outside on the moon's surface, which was 1/6 Earth's gravity. You did science experiments, you did all kinds of things for us. And then you eventually drove a rover, and then you'd launch off the moon and come back home and land. So think about all the different body postures. Now we're seated on our back. We're walking, we're standing, we're kneeling, we're picking ourselves up. They did fall occasionally.
Yeah.
And we're floating. So this, in my opinion, has been the most complex suit we've ever designed for spaceflight because of all of those different body postures and capabilities. Now the interesting thing about the Apollo suit, aside from everything else, is that it had its own independent life support system. The Gemini missions, part of the problem that we had with maneuverability and mobility is that the life support came in through an umbilical, kind of like what you see here. So a big cable that is providing you with precious life support, such as oxygen and cooling water and battery power, everything that you need to survive your spacewalk during this extreme environment. Well, you don't want anything to happen to that cable, right? But what's going to happen when your astronaut can't maneuver in space and they hold onto it and start tugging it because that's the only thing that they can grab onto? Well, we also realized that that limits how far away from your home you can go. And on the Apollo mission, we didn't want to be held to an umbilical where we could only go even feet away from the habitat. We wanted to go miles, especially when we had a rover that we could drive around. So the Apollo spacesuit was the first suit that had its own independent life support system, the backpack, we love to call it. And if you'll notice, it had to be removable because, again, you needed to wear this suit during launch and re-entry, so when you're on your back or in a seat. So this backpack had to come off, which is why all of those cables are coming to the front of the suit. So we went away from a big, long umbilical to teeny tiny ones that they could connect when they go out on a spacewalk and then disconnect. We learned a lot about doing science on the moon while we were there. That's good. That was one of our key objectives. But as tool designers, which is something that we do in this division, we learned a lot about how to make tools that are for essentially moonology, not geology, and what would work well and what wouldn't. I like this little tool carrier here. It's kind of triangular, but after they used it on their Apollo mission, they came back and said, basically, it was like carrying around a big purse. Now, gentlemen, I know you feel me on this one, right? But ladies, you know, if you carry around a big purse, so you have a bag with you, things get lost in there, don't they? Whether it's a carry-on bag, you know, a backpack, anything like that, you know, a merce, whatever. So we had to redesign not only the tools every single mission and figure out what they liked to use, what worked, what didn't, but also the way that they would carry them around. We found that because they were inflated and they're in a gravity environment, each astronaut actually moved a little bit differently. Even though we trained them here on Earth, even though we put them on devices to test out and teach them what it's going to feel like, it was still not the same, and every astronaut moved a little differently. So now think about clothing design for people that some people like to hop, some people like to skip, some people like to kind of gallop, some people really tried walking, and others bunny hopped, and others shuffled. And every astronaut had some kind of an issue with their mobility, but they got the job done, and we did it well. We have 12 astronauts that walked on the moon in these very suits. The Apollo suit was also used during the Skylab missions when we do a few microgravity EVAs there. They were primarily to retrieve film canisters, I believe, on those missions. So we learned so much about exploration, spacesuit design, and space tools design, and then NASA shifted its focus back a little closer to home, to low Earth orbit. Part of the reason was budgetary, part of it was political, but also a big part of it was our science exploration goals. It took 2 to 3 days to get to the moon. This is 2 to 3 days of transit only. The missions were about 2 weeks long. And that's putting our astronauts and our crew in a very, very hazardous situation to the extent that we might not be able to help them out if there was an emergency. But we also wanted to get a lot smarter about living and working in a space environment. We realized that if we wanted to get better at that, we needed to do it much more frequently than 6 lunar missions. So we shifted our focus to low Earth orbit, and we realized we needed a new vehicle, now one that could house not 1, not 2, not 3 astronauts, but 5 to 7. Something that could launch like a rocket and land like a plane with reusable parts so that we could do multiple missions per year. Well, our spacesuit engineers said, you know what, the Apollo suit did really well, but it wasn't optimized for any one condition. So we still had problems with it, kept our astronauts alive and allowed them to do the work that they needed to. We got a little bit smarter about our suit design, and we said we need 2 suits for the space shuttle program. They're over here. Okay. That trip took us 8.5 minutes to get into flight. So now 8.5 versus 2 to 3 days, quite a difference, right? So accessing low Earth orbit is much easier. The 2 suits that you see here are the launch and escape suit, or the advanced crew escape suit. This is what the astronauts wore during launch and reentry on the space shuttle. And then the extravehicular mobility unit, or the EMU. This is the US version of the spacesuit that we wear to go outside the spacewalks. So the crew escape suit is really just for that 8.5 minute duration into spaceflight, and then for your return home. It has all of the equipment that we thought you would need if you had to bail out of the space shuttle. So it had a parachute, a life raft, supplemental oxygen, things like that that you would need. So it was once again a get-me-down suit, more like the Mercury suit. The extravehicular mobility unit is a very specialized suit. It's the only suit ever designed with one purpose in mind, and that is microgravity spacewalks. Not every astronaut gets to wear this one. You have to be specially selected and trained. It includes extensive underwater training. You guys have been to the NBL, right? No. No? Are they ghosts? No.
No.
Look
been
it up, and then
before.
you know what? We call that trip insurance. You know, whenever you go somewhere and you don't get to see it all, you mark it down in your notebook and you say, well, that ensures that I'm coming back. So definitely check it out online. But the Neutral Buoyancy Laboratory is our big underwater training facility that we have just a few miles that direction. Well, so we include extensive training in this suit, both underwater and on our reduced gravity aircraft, because the work that they did for the construction of the International Space Station really involved a lot of physiological effort, metabolic effort to work in this suit. It is not a joyride. It is 6 to 8 hours of pure exercise. There's very little time that they'd spend actually sitting and looking around. They get to do that inside, maybe, if they're lucky, on their personal time, right? I'm kidding. Okay, so this suit, it's a modular suit. Now, the US spacesuits, we like to fit a variety of shapes and sizes of astronauts. We have tall astronauts, short astronauts, big brawny dudes, and petite, tiny females like myself. So I like to think of the spacesuit as a big puzzle. Do any of you like puzzles? Mm-hmm. Yes? Well, you can be an engineer like me then. Yes, it's a big puzzle. We have to figure out how to size each of the different elements. So we go through an extensive set of measurements with each astronaut and the suit. We do a lot of fit checks to make sure it's comfortable, both pressurized and unpressurized. And then the gloves are where we really make sure there's a really good fit as well as we can. We can do about 40 different sizes of gloves. Now, in contrast, we only have about 4 sizes of shoes. But even though we call it a spacewalk, are you walking?
No.
No, you're floating, right? So do your shoes need to fit well? Not really. Here on Earth, though, what happens if your shoes don't fit well? You get blisters, it's uncomfortable. I mean, think about the shoes you're wearing today. How they feel?
Does it make a difference when they're on the end of one of the robot arms, the Canadarm or whatever, in those foot?
We try to get, if they're uncomfortable with the foot, the shoe fit, there is a slipper that they can put in there. So, yeah. So there's only a few sizes of the boots. But when you're on a microgravity spacewalk, your hands actually they work as your hands and your feet. So your gloves have to fit well. So the glove design has gone through a lot of different design iterations to make sure that we get the mobility and flexibility and the tactility that we need. So from the top down, you've got a helmet. Of course, you need a helmet, right? It's your pressure bubble. That's how we put the oxygen into the spacesuit. It goes right across your face so that you get good, clean breathing oxygen, and it blows out the carbon dioxide. When you're on the sunny side, you pull the visor down. It's your spacesuit sunglasses. And then you see you've got camera lights, headlights, and sometimes we put cameras up there so that we can record what's going on. Moving down, what you see on the front here with this metal structure is what we call the display and controls module. We all have a dashboard for your car, right? Well, the spacesuit needs a dashboard too. This is how you control and monitor the health and the systems of your spacesuit. On the top, there's a tiny liquid crystalline display, and the astronauts can toggle through that to check the status of their spacesuit systems. On the very front, you see that round dial that says H010 to C. What do you think that would control? H to C, hot to cold. And what would we want to control hot to cold?
Because it changes from night to day to night to day to night.
Good. And the extreme temperatures on the outside and how much you're working on the inside. Basically, that's essentially your air conditioner control, except we don't have air conditioning in the suit. We learned that from the Gemini missions. Yep, and the Gemini missions, part of the reason that the astronauts got so hot working in their suits was not only because of the lack of mobility or the restricted mobility in the suit, but also because we were relying on that oxygen to cool the astronauts, and it wasn't enough. Think about it outside, you're walking around on a hot summer day. If you need to cool down quickly, is it faster to step in front of a fan or an air conditioner or jump in the water in a swimming pool? Right. So because of the heat transfer properties of water versus air or oxygen, water is a better cooling system. So we have a cooling system underneath the suit. It's a liquid cooling garment, spandex. We love to put you in spandex at NASA. And now, not only are you in a tight-fitting garment, it has tubing running through it. So you look a little bit bulky, you know, and yeah, it's good. But you're very appreciative of that suit when you get hot in this spacesuit. So the astronaut can control the temperature of the water flowing through that liquid cooling garment. You can also control the volume of your communication system, the pressure of the suit. So really that's your spacesuit dashboard. The structure that you see connected in here is really your tool belt. It's a tool caddy. A lot of what they're doing outside on a spacewalk is either building their home in space or maintaining it. So they need these tools very close to them, and you don't want them to float away. So that's your tool belt. You've got a lower torso. This is your spacesuit pants. No one goes outside without their pants. It's a good rule of thumb, right?
Now they tell us.
Yeah.
Is there something you're
I feel like I'm missing something. So the spacesuit trousers and then the boots connect in as well. And then we still have the life support that is fully independent. They're outside for anywhere from 6 to 8 hours. So that backpack has all of your primary oxygen and your emergency oxygen. If you were to get a hole in the spacesuit about the size of a ballpoint pen diameter, you could last for about 30 minutes because that high pressure oxygen is going to flood the suit. You can get back inside safely. You've also got the cooling water tank in there, your battery power, all of your communications equipment, and your sensors. We really think of this spacesuit as your own personal space vehicle. It is designed to keep you alive for the duration of your space mission. In this case, it's 6 to 8 hours.
Does that ever happen? Or like puncture 30-minute kind of thing? Is that
No, we have not had that. Thank goodness. Thank goodness. Yes.
Are y'all still working on the problem of the fingernails and all of that with the gloves?
Yes. What we found is that because we tend to be hot, sweaty, toxic gas producing carbon structures inside of a very well insulated device, you definitely get warm in there. That cooling garment ends at your wrists and at your ankles. So we do allow them to wear, if they choose, a comfort glove, which is basically a really thin material, kind of to wick the sweat away a little bit from your hands. But we find that when they're training in the neutral buoyancy laboratory, because you're a humid astronaut inside of a well-insulated suit surrounded by water, the inside environment tends to get even more humid, and they get fingernail delamination. So your fingernails start to get really weak and split apart, and it's not good. So we've done a lot of studies on what we can do. We don't see that as much in space. I think it's mostly in the NBL, but, well, you know, it's a funny thing when you have a team of astronauts that are both male and female. You have to make sure, that's why white's a very nice neutral color. It's good for everyone, right? It's also good for thermal protection, radiation protection. It's also the opposite of black, which is the color of deep space, so I can spot you easily when you're on a spacewalk. But it's also not male or female specific, right? So when we were looking at solutions for that, one of the solutions was to paint clear coat nail polish on.
Wow.
Make sure it's good. There's some problems with that because of the off-gassing. If you've ever used nail polish, again, guys, you're with me on this, right? Yeah. When you're at the manicure place, it has that fume, right? That's called off-gassing. That's very bad when you're inside of a closed loop environment. So that's one of the problems, is finding one that doesn't off gas, and then the other is, frankly, the guys don't really want to paint their fingernails. So
Starting to lose it.
that's true. That's true.
Have they modified the EMUs at all for station, or are they exactly the same as shuttle?
No, we've made modifications over time with some of our hardware. The gloves have evolved over time as we've gotten a little bit smarter about the mobility and dexterity that we need for spacewalks, as well as the hard upper torso, which is the structure that goes underneath that kind of collarbone. It goes from your collarbone to your rib cage. We've looked at different angles of that, because one of the problems that we find is that it's pretty hard to slide up into this, and you kind of have to maneuver your upper body, and if you're a little bit inflexible, it's going to be very uncomfortable. But to get that good suit fit, it needs to be a little bit tight. So absolutely, and we're always looking at upgrades and modifications. We always want to improve so that we can do things better within our capability of doing so. Now what I can't show you today, which I'm waiting for us to put a display in here any day now, is our future suits. And these are the suits that we're working on for exploration of the moon, going back to the moon, onto Mars, or to an asteroid. So these suits are in development. And if we'll walk over here, I'll direct you to where you can find videos about them. So since you're all social media folks, right? That's mine. Yep. Feel free to connect with us on Facebook. We're the Crew and Thermal Systems Division. If you connect with this Facebook page, you are connecting with me. I'm the one and only person that writes on this page. But this is where I load pictures whenever we have new updates to any of our hardware test videos. And if you go to our Facebook page, you will get to see a video of our new Z1 spacesuit prototype that we just released. So feel free to like us. That is my absolute positive advertisement. And feel free to invite others to like us.
Cool.
I try to post about every week. If you look on there today, you will notice that I sent a greeting to you and the Israel Space School students that have come here. So, and also the link to the NASA social blurb for the April one, I think at Goddard. So, if there's anything interesting happening in my engineering division, or if there's something that I see that NASA is doing that is of interest, whether it's to students or educators or just anybody, I try to post it there. I post stuff about International Space Station research, anything I can find. So,
Just about out of time, so any final questions for us before we head back?
good.
Really cool.
Awesome.
That's great.
Thank
Thank
you.
you.
So awesome.
Oh,
Are the
you
new
know.
ones you're working on the ones where they climb into the back?
Yes.
Take a picture of
Yes,
that.
that
Do
is
you
one
have
of the
to
new
have an
designs.
app to do that?
Thanks to
QR
Russian
reader.
Orlan spacesuit.
Well, I
it's
have
a lot
different
easier to
things.
get
Somewhere I
into.
know I have a
and
backup
I do realize
app.
that.
I'm Android.
They started all
Android.
that.
Yes.
See, I don't know anything about Android.
Yes.
Is there like one primary line that you're working toward, or are there multiple different kinds?
Can we just look him
we're,
up?
We're working on the
CTSD.
Orion
No, I had something.
The vacuum.
crew escape suit,
I'll get a picture of it
basically
and
like
send
the
it to you.
orange suit.
Okay.
Taking what we know about naturally
Spacesuit or just escapes?
Right now, it's all up in debate, but right now we know they're gonna need
It's
it
just
for
taking
launch
a
and
picture,
reentry, so
probably.
that's what we're working on.
Do it.
But
Well,
we
it'll
are working
scan
on
it.
the suits, you know, and
Let me
we
send
have
this to
several
you on
different
Twitter.
prototypes that we have right now. Most of them, I believe all of them now are rear entry. So where you open the hatch, slide in, close it, done.
But it's not even necessarily to the point where it's nailed down. This is pretty much the design.
Not yet. We really need a
What's your Twitter handle
destination.
My Twitter
You know, I
handle?
mean, there's only so much.
IB.
You know they're
Oh,
gonna
wait,
need
yeah, I
to
found it.
launch,
Happy
we know
Hopi.
that the gravity level is
Got
gonna
it.
change, how they
So
do that.
once you have like a destination in mind, how many years in advance do you
Appreciate
figure
it.
out
Yeah, no problem.
to get the suit ready? Does it take like your designer suit?
I think I'll let you scan it that way at some point.
Well, we've already
Well,
been working on
somewhere
that.
I had
We've
one.
had simulated missions in the Arizona desert and under the ocean to try and figure out what we would need depending on where we were going.
Right.
You know
We've already
how
got a little bit of
gremlins
history.
get in there.
I've seen some of that, but like once you like
Once,
this
if
is it,
they
and
were
you
to
do the
say we're
final-
going to we're going to Mars and
Yeah.
it's 10 years away, could you build a suit? I'd say yes.
10 years, yeah.
Yeah. 5 years.
Probably, maybe.
Well, what we'd have to do is decide between upgrades to what we've already designed or use what we've got, kind of thing. So, I mean, if it was 2 years from now, it would probably look similar to something like the Apollo suit, or the EMU, with upgrades and mobility. Yeah, but I couldn't tell you. I don't know. I know we're working on it, so. Right, guys. Great.
Very good.
Thank you, guys.
Thank you.
Very much.
Thank you.
Enjoy the rest of your time.
You have
Don't
a lot
forget
of lights.
to come back.
Yes.
Yes, and we've only been around for just over a year.
Follow Brandy.
I know.
3,400, you're doing
Well,
well.
there you go.
Fill up one.
I know.
I'm just gonna go look in the building to see what I can see. I was in the Pentagon a few years back. And I saw the commanding general of the Air Force in his office. Nice. He didn't send it back. Not that I was misbehaving or anything. Thank you. It's okay, whatever bus we're on automatically becomes the cool bus.
I know.